So this is the last lecture for Part A, and we begin with the revision of the data type that we have studied so far. So these few data type we have studied. So first is double. Double can be integer, can be decimal, okay? And complex we haven't studied, so you can remove this line. And then we also have we also studied string, or we call it character. So when you define a string, can be letter, and can be number, can be special characters. But when you define them, you must put a single quote around them. Okay, here. So the fourth type is called logical data type. Logical data type normally happens when you compare something. For example, a matrix with a number, or can be other things. But when you do this comparison, then the outcome can be true or false. For true, we use 1 to represent. False, we use 0. So this 0, 1 is not really double data type, okay? It's not a number, it's a comparison result. And then the last type we studied is called function handle. That we studied in last lecture. This function handle is, in fact, is a variable, and this variable points to a function. So you call this variable with a certain input, it's equivalent to call that function with the same input. So this is the function handle. So other data type that we haven't talked about, but I can give you the brief idea of what are they. The first is single. Compared with double, double can support 64 bits. Okay, and here single is 32 bits. And this is the first data type we didn't cover. And then we also didn't talk about, there's a few built-in function. So integers and signed integer. So these first integers can be int 8, 16, 32, 64, and so on. So what is that talk about? For example, int 8. So this is to say, no matter which value you input, if you say int 8 of that value, is giving you, first of all, integer. Second of all, this integer must within a certain region. So int 8 means must within 2 to the power of 8. Okay? Divide by 2. Why divide by 2? Because it has sign. That means you have plus or minus. Okay? So this is minus 1. So this range. So 2 to the power of 8 divided by 2 is actually, it's from minus 1 to 8 to 1 to 7. This range. For example, if your input is 1,000, if you use int 8 of 1,000, so it beyond the supporting range. So it will go back to the highest possible value, which is 1 to 7. So this is the idea of int 8, for example. So it will run back, okay, because it can only support the certain region from minus 1 to 8 to 1 to 7. This is integer int 8, and a similar thing happened to integer 16, 32, and 64. So there's similar to int 8, we have unsigned integer. It's the same idea that you can, whatever input you put in, and then it will return you an integer. And this integer have a range, okay? So this unsigned integer is also 2 to the power of 8. Because it's unsigned, it only have a positive side. It don't have negative side. So it's going to be from a 0 to 2 to the power of 8 minus 1, okay? So this is going to be 255. So for example, we say unsigned So it gives you 255. It's still, if you're beyond this range, it pull you back to the highest integer it can support. So this is the other data type, but we really seldom use this kind of data type. And the last comment, so in fact, I start talking from who. So if you type in who, it lists you all the variables you're currently using. Okay? So if you say whose, put an extra s here. So give you not only name, also give you size and what type. Okay? Give you all the detailed explanation of the variable you are using. So this is the some built-in function. And now we start talking about data. Okay? So the data normally we are using is decimal. Okay? So, but in the computer or in MATLAB, their computation are based upon binary. So how do we convert binary to decimal or vice versa? So have you ever studied this before? Okay, let's take one very simple example, how to manually compute. And then later we will show you MATLAB can help you to compute. It's just using one built-in function is very fast. So let's take an example. For example, we use binary, 0, 1, 0. Give you, this is binary. Binary means either 0 or 1, okay? The 3 digits of the binary. So this is a binary number. And you're supposed to go to decimal, okay? So how do you do it? So first you put position of each digit. So the first digits from this sequence is from right-hand side to the left. So these first digits, let's say position is 0. The next one, position is 1. And the third one, position is 2nd. So this is actually, you can think they are index or positions of the digits in this binary sequence. And then what you do is, for example, this position is 2nd, so you can put 2 to the power 2. This is, the position is 1, 2 to the power 1, and the last one is 2 to the power 0. So it's a binary based, and then to the power of the position. And then these 3 give you 3 different integer. And this integer gonna be weighted by this binary sequence, 1 by 1. So the first one in this position, okay, gonna times 0. And plus second position scaled by 1. And then the last one scaled by 0. So the sum will give you actually 2. So 0, 1, 0, this is binary. And when you convert to decimal, it's just 2. Okay? So it's a weighted linear combination. And the binary is the weighting coefficients. And their position, 2 to the power of their position, going to be the true value that you're going to combine them. So if you think, then what happens, give you 5 digits, 6 digits. It's a lot of computation that you're going to do. So can we do it using a bit easier way? So MATLAB here provide 2 built-in functions that help you to work out this. So one is called a binary to decimal, and the other is a decimal to binary. Let's try. So, for example, you want to put the same binary that I computed, 0, 1, 0. You want to transfer them into a decimal. So binary to decimal. This is a built-in function. When you use this built-in function, with a certain input argument. This input argument is a binary input, okay, either 0 and 1s. When you input them, you must have a single quotes here. Otherwise, it won't work. Okay? If you happen to forget about this single quotes, it will happen to have error. So this is how to use binary to decimal, this built-in function. And there is another example. Now, decimal to binary. Okay? So when you input decimal, for example, 10, and to binary, and when you use this function, built-in function, you input decimal, then you don't need to put these single quotes. Okay? So this will give you the binary. So this is the two simple input function, built-in function, binary to decimal, decimal to binary, that can solve the computation problem for you. Okay, any question? So now we mainly talk about all numbers, our data. Then we, in the following lecture, we're going to talk about a few different kinds of error. Okay? We start from an example, this example. So this example is to saying you have two built-in functions, real mean, real max. This will give you the smallest and largest positive value that MATLAB can support. So for example, here, we first type real max is the positive maximum number that MATLAB can support. So it's like 1.79 times 10 to the power of 308. So real mean is the positive minimum number that MATLAB can support is 2 times 10 to the power of minus 300 something. This is almost 0. Okay, so this is the largest positive and the smallest positive number MATLAB can support. So what happens if you input A, for example, can be any real numbers that you input. So the A absolute value, if it's greater than this real max, okay, beyond this, then MATLAB will have overflow. Overflow means your input is too big, is beyond the maximum positive number that MATLAB can support. So it will incur overflow. There is an error. Okay? So what MATLAB will indicate overflow is to return infinity or minus infinity, depends on your input. For example, my input is 1,000 to the power of 1,000. This absolute value is absolutely greater than this real max. So in such a case, overflow will occur, okay? And what MATLAB will return is infinity, okay? But what happens, I put a negative sign here. Does that change the result? Okay, because the overflow, the definition is absolute value. So if you have your input is a negative value, and absolute value is still positive, so it's still greater than real max, you still incurred overflow. But what MATLAB will return to indicate this overflow with a negative sign here is minus infinity. Because your input, this plus or minus sign, follow your input. If your input is positive, and then it's positive infinity. If it's negative, negative infinity. Whenever your input is too big, okay? So let's say, for example, 1,000 to the power of 1,000. This is too big. This is absolutely will cause overflow. Okay, it's infinity. And the same thing, but we just put a negative sign here. It gives you infinity, but with a minus sign. But no matter plus infinity, minus infinity, they both belong to overflow. Okay? The result doesn't change. It's overflow. Okay? So this is overflow, and if you have overflow, then you're going to have underflow. Underflow means your input A absolute value is less than real mean. This real mean is the minimum value that MATLAB can support, positive numbers, okay? So if your input is less than real mean, then you incur the underflow. And underflow, MATLAB will return 0. For example, 1,000 to the power of minus 1,000. So this is a very small number, okay? This is less than real mean. So MATLAB will return 0 to represent. This is called underflow. So this is a basic concept that it's very important we should understand, okay? And this is a few examples that I just demonstrated to you. Overflow and underflow. And there is another important, is called a format. Format command. So format, for example, long. So what does format long means is you print out 15 digits in total, you can. Okay? This totally you can count is 15 digits. If you think it's too long, we say that format long, format short, right? Yeah. Format short, it's up to 5 digits. It's up to you, which length that you want to print out. This is the format command. And format command, another important application is a format, for example, loose. Okay? For example, format loose is to say when you print out, the line and line spacing is very big. Okay? So this is a format loose. And format compact. So that means line and line very tight. The spacing is very tight. So this is the few easy examples of building function about format. So we continue about errors. So this error is called a round-off error. This round-off error is because, for example, 1 minus 6 is going to be 0.166 and continue. This is going to be infinity. So when you deal with this kind of data, you cannot perfectly store them in computer. Okay? So because of this kind of thing, you cannot represent perfectly in the computer. You cause this round-off error. So what is this round-off error? This round-off error is going to be very tiny, but it will grow bigger if you use a for loop. If it happens in the loop, it will become bigger and bigger. So let's see an example. This example is very easy. Is this computation. This computation is without MATLAB. If just you do this computation, it's very easy, right? So 11 multiply 15 over 11. So 11 cancel. 15 minus 15 is just 0. But when you do this computation in MATLAB with the brackets, so what MATLAB will do is the brackets first. So MATLAB will compute this part first. 15 divided by 11. So this will be an infinite number. Okay? It will have an infinite length. But here we, of course, that computer will truncate them. Okay? So this will cause some trouble because MATLAB cannot store them perfectly. And multiply 11 minus 15. So that's why it will give you a very tiny error. This is called a round-off error. I'm going to demonstrate you here. 15 divided by 11 minus 15. So you see this is some round-off error. So this round-off error normally is very tiny, but if you use for loop or other loop, it accumulate, can be big. Let's see an example. This is an example of round-off error. So what is this example telling you? We start from here. Okay? So summation, my sum is 0. And then you have a max number. This is just 10 to minus 8, 10 to the power of 8. So then you use a for loop. So n is like a counter vector from 1 to 10 to the power of 8. And every time you are summing at 1 over 10 to the power of 8. And how many times you're going to sum is 10 to the power of 8. So totally you should get 1. But unfortunately, when you sum this 1 over the maximum n, this cannot be stored properly in MATLAB because it's too small. And then it causes round-off error. Okay? So when you have a round-off error, you will see the sum, although you manually compute, is 1, but then it won't be 1. Okay, I'm demonstrating you this example. So this is the example I mentioned. So you can clearly see that there is a round-off error because my sum is not exactly 1. You have some extra part because MATLAB cannot store some real numbers properly. This is round-off error. And that is one round-off error. The second error is epsilon. Okay? So what is epsilon? So epsilon, for example, I take an example. Start from epsilon. Normally we say epsilon 1. What does that mean? So you have a, for example, real number. Here is 1. Okay? And the next possible real number that MATLAB can support and print out is what? Is here, for example. The next available real number that MATLAB can support is here. So here is, in fact, is 1 plus epsilon 1. So what is epsilon 1? Epsilon 1 is just the distance between 1 is the next available real numbers. So it's a distance. Okay? It means this distance. So, for example, how big it is 2 times 10 to the minus 16. This is the smallest distance that MATLAB can support. So how about you say, oh, now I compute 1 plus epsilon 1 divided by 1,000. So you are 1 plus a small number, which is even smaller than this epsilon. Okay? So this epsilon is truly the smallest gap that MATLAB can support. If you say 1 plus some distance even smaller than epsilon, then MATLAB cannot support that distance. So MATLAB will treat this part to be 0. So then it will be 1. Okay? So this is another point may incur error, also called a round-off error. Let's see an example. So this example asks you to choose A, B, C. You have a go, and let me know which one you're going to choose. And remember, here is epsilon 1, okay? And this number is smaller than epsilon 1. So can you tell me which ABC, which one you are choosing? Sorry? Give me ABC, which one? Someone said B, someone said C. So tell me why you said B. Intuition. Just the first guess. Yeah. And why you choose C? Someone choose C. Yeah. Okay. Because actually in the for loop, what you do in minus or plus doesn't matter. This minus or plus doesn't matter. You plus a number which is even smaller than epsilon 1. So epsilon 1, I've mentioned this is the smallest distance that MATLAB can support. If you plus something which is smaller than that, MATLAB will treat this part as 0. So no matter how many times you are doing the for loop, you will, every time you plus or minus 0. So that's why the final result should be 1. Okay? So this is the just testing you about round-off error. So another point about round-off error is not truncation error. So we talked a lot about this sign-Taylor expansion. We said, oh, sign-Taylor expansion is to take infinite n terms. But then when we compute, we just take the first few terms. That is called truncation error. Truncation error is an error that you make, okay? But a round-off error is not a truncation error. Round-off error is because MATLAB cannot support real number properly. So it's some error MATLAB make, okay? So this is the difference between round-off and truncation error. This error, how to measure error in programming, this is very easy to understand. So we just gave a quick review of the definition. So the first is relative error. Basically, it's approximation with the true value, the difference, normalized by true value. Okay? And percentage error is just relative error times percentage. Okay? And absolute error is just approximate error, approximate number and true number, the absolute value. So these three errors. And how do we measure this error? So defined as accuracy and precision. This accuracy and precision you can classify in this picture. So this picture, imagine this center point is a true value. And now you see the all black dots is all shifted far away from center point. We said this accuracy is not good. When is the accuracy is good? Is all the measured point, approximate point, is very well evenly centered around the true value. For example, here, this is good because they are evenly centered. Okay, this we say accuracy is increased. And how about this part? So this is one point, accuracy. So what is the precision? Precision is saying how much the measured value are well matched to each other. That means you have a data set and they should be very close to each other. So this is very sparse. So this is very bad. So if you want increase in precision, this is good, okay? Because they are grouped together. They are very close to each other. And if you say, I want good accuracy and good precision, then it's going to be this one because it's centered at the center and all the measured value are grouped together. Okay? So this is how we define accuracy and precision of the data. So the last point is writing MATLAB codes, efficient MATLAB codes and fast. We start from an example. So this example is related to the pre-allocation. So what is this example is telling you? For example, you assign 1 to 4 to A. So what MATLAB will do at the beginning is create space. Okay, 1, 2, 3, 4, and then put 1, 2, 3, 4 in. But then, and then second time you said, oh, you define the fifth element is 5. Okay, so what MATLAB will do is then remove all this space it created and resize it, recreate a vector A which have 5 space, and then put 1, 2, 3, 4, 5 in. Okay, so imagine you are in the loop. Okay, you don't pre-allocate, you just randomly add in the elements. So every time MATLAB will have to resize it. So this will delay, will slow down your MATLAB programming. So what we can do normally is pre-allocation. So here, the red box is without pre-allocation. This green box is with pre-allocation. Pre-allocation is very important when you deal with the large dimension of matrix and vectors. So here is giving you a large number, 6 times 10 to the power 4, and then you do a for loop. Every time you just compute this value, okay, and assign to this matrix, my matrix 1. So every time you assign this, that MATLAB will resize. Okay, this resize will slow down the MATLAB codes. So later I will show you how much it will gonna spend compared with pre-allocation. So this is inefficient. So what can we do is we first, before assign all this value, we pre-allocate. Pre-allocate means you can create a matrix with this size, but put all zeros. Okay, so then MATLAB will create a column with all 0 in. And then you assign using for loop each element. So what MATLAB will do is, oh, here is 0, here's 1, here's 4, and so on. We'll update accordingly. But this size only create once, this space. We'll only create once. So this saves some running time of MATLAB. So I'm going to compare this running time. What's the difference between them? So one is no pre-allocation, one is pre-allocation. Let's compare this. So now we go to tools, and there's an open profile. So this open profile is to compare the timing that you used. So clearly, you see the pre-allocation compare, that's no pre-allocation here. How many times you spend? It's 6.17 seconds. And if you do pre-allocation, you don't need to resize every time, and then you only use 0.015 seconds. So you save a lot of time in that way. So this is the why we use pre-allocation. So the last example, let's finish as a last example, is this example. This example is to saying, if you want to make MATLAB program very efficient, we're going to change majority of time we don't want to use for loop. We're going to use a vector to represent this for loop. So we called a vectorize the codes. So I give you maybe 1 minute to read these MATLAB codes. So this MATLAB code is basically not vectorized. Okay. So now we go to read this line by line. So first you give a T star, T end. Ni is 10. From 0 to 10, Ni is 10. And then you calculate T1, Y1. And then you use a for loop to calculate T and Y in general. And finally, you plot T and Y. So in this entire code, what do you care? You care 2 variables. One is T, one is Y. And both T and Y, you can tell it's a vector. So once you notice T and Y are vector, then we can vectorize. Okay? So let's first focus on T. What is T? So T start from 0, T end 10, and the T1 here from T start, with T start is 0. How about Ti? So in the for loop, Ti is basically previous value plus T end. T end is 10 minus T star, which is 0, divided by 10. This is just 1. So it's a Ti minus 1 plus 1. So from this observation, this and this, these 2 lines, telling you this T vector starting from 0 and in an increasing order with step 1, right? So instead of using for loop, we can vectorize. We say T is nothing but a vector from T start to T end. And step 1, because this clearly tells you the step is 1. Okay, this is first. We represent T instead of using loops. We just write down one line to represent T as a vector. Now, the second element that we care variable is Y. Let's look at Y. So Y1 is actually calculate 10 plus 5 cosine 2 pi t divided by this difference between end and start, which is 10 here. Okay, this is 2 pi t. Okay, when the index is 1, it's just t1. And how about index is I? It's just ti. So then what is y? Y is nothing but, you can also write a vector style, is 10 plus 5 cosine 2 pi t, okay? Divide by t end minus t star. So this whole thing can be rewritten as the first line is t, second line is giving y, and then third line is just a plot t and y, right? Any comments? So here is sorry. So here is not vectorized, okay? And here is vectorized. Like what I said, is first you give t, and then you compute y, and then you plot. So here is the result, okay? So this example is nothing but telling you sometimes no need to use for loop, just no need to use it. What you can do is just try to vectorize the MATLAB codes because it's fast to use vector and matrix in MATLAB. Okay, so that's pretty much for today. Any question, feel free to ask.